So if you remember, in the previous session, we had discussed about OSI reference model where we have seen the basic 7 layers. In that, application layer, presentation layer, also we have seen application layer provides a user interface, presentation layer defines the format, session layer creates and maintains and terminating the sessions. Now, once we do that, the next layer which we'll be discussing is a transport layer, which is responsible for end-to-end transmission of your data. And to do that, there are multiple process involved in that. So we are going to see in detail about what are the different process happens in the transport layer. And this transport layer is majorly called as the core layer of the OSI model. Why? Because it is going to interconnect your application with your hardware devices. So let's get started with our transport layer. The transport layer is responsible for end-to-end transmission of data, transportation of your data. So the major task includes here are identification of service, multiplexing, demultiplexing, segmentation, sequencing and reassembling, error control, flow control. So these are all the different types of process happens. So to provide end-to-end delivery of the data, so it is going to use different mechanisms to do that. Okay, in that the first one, let's talk about identification of service. So let me come down to my the first thing, identification of service. So let's start with identification of service first. Now, identification of service, if you remember, when we are initiating any application, so we are not sure which application we are using. Maybe I'm sending and receiving my web pages, or maybe I'm sending and receiving some files. Maybe I'm some verifying my mails. So probably it can be any other services. So now when application layer initiate the process, that is going to use specific protocols for these things like a file transfer protocol for FTP, HTTP for web traffic, mail servers like we generally say SMTP, depending upon the type of the service. So once this application reaches the transport layer, once it reaches your transport layer, the transport layer is going to use identify the services with the different port numbers like HTTP on port number 80, and then it says FTP on port number 21 and SMTP on port number 25, similar way Telnet port number 23, like that. So now each and every service will be identified with different port numbers, and once it reaches the transport layer, now transport layer provides end-to-end delivery of the data by using only two protocols. There are two protocols involved here in TCP/IP. We call them as UDP and TCP, transmission control protocol, user data gun protocol. So now these are the two protocols which are responsible for identifying the specific service and then sending the data. So now when it is doing that, there are multiple steps involved here. Like we discussed here, identification of service, the first one, multiplexing, demultiplexing, multiplexing, demultiplexing, segmentation, sequencing, reassembling. So let's try to understand one by one identification of service. First, let's start with segmentation. So now the segmentation is a process of dividing a large packet into smaller packets. Segmentation is a process of dividing a large message into smaller messages. Let's take an example. I have some two devices connecting from both the ends, and I'm going to pass on some information from this device to another device. It can be in the LAN, WAN. So the message is, hello, how are you? This is my message. So now in general, the packet size will be very big. So what generally it will do is it is going to divide that particular information into multiple parts. And this process of dividing multiple parts, we call it as segmentation. So now once it divides, now it is going to send each and every part from all the possible routes, which means your messages will go from here, or you may have another route from here, you have another route from here, or another route from here, like that. It is going to use all the possible routes to reach the specific destination. So now once the packet arrives at the destination, now there is a possibility that you may receive the information in a random order. Maybe you don't receive in a same order the way it has to be. Now it has to go in this order: hello, how are you? So now there is no meaning for this statement, because you are saying are you, how, hello. and question mark in the end. So there is no specific order for this information. So to overcome this again, so when it is doing segmentation, at the same time it is also doing something called sequencing. So we are going to discuss one more method, sequencing again. So sequencing is a method of adding some information to the existing frames. Like it will add, this is the first frame out of 5 frames, or first packet, first segment out of 5 segments. This is the second segment out of 5 segments, third segment out of 5 segments, fourth segment out of 5 segments, and the fifth segment. So now when it reaches the destination, even though you are receiving in a random order, let's say you have received in this order, so but still it is going to see this information, and based on this information it is going to reassemble them in a proper order. So again it will reassemble as hello, how are you, because now it understands this is the part 1, part 2, part 3, part 4, and part 5. So we call this process as reassembling. Reassembling is the process of rearranging them in a proper order. At the same time, not only this, it also do something called error control. Now the error control job is to ensure that when you're sending some 5 packets, so I'm going to send some 5 messages or 5 segments. So when you're sending some 5 messages, now by default, if you're using some TCP protocols, the TCP protocol is responsible for doing these jobs, or UDP sometimes. Now the basic difference between these two we'll get into more in detail when we discuss the next topic, TCP IP. Okay, so now what generally happens here is when you're sending the information, so the receiver is going to acknowledge you all the 5 messages, so which confirms that you have sent the information properly and there is no drop in the messages. And in case if I did not receive, so I'm going to send all the 5 messages, 1 2 3 4 5, and the receiver acknowledges only the 4 messages, which means the device will understand that any one of the message has been dropped, or maybe due to some network congestion some segments has been dropped. So now it is going to resend that particular segment. So now the source will wait for some a specific amount of time waiting for the acknowledgement, and in case if it did not receive the acknowledgement, let's say if all the segments gets dropped, so it is expecting this acknowledgement. So if it doesn't receive that acknowledgement, so it will wait for a random amount of time and it will resend all the information again. So we call this as error control. Okay, apart from that there is something called flow control. This is also happens here. So flow control is a mechanism to restrict how much amount of segment or how many packets should be sent at one time. So let's take an example. I'll just take an example of my class. Let's say I'm going to take a class on OSI model. We'll be discussing on it, and once we finish this, we discuss some basic IP addressing, and once we finish that, we also discuss something on subnetting. So if I say today we are going to discuss these things, so but when I try to force this information, probably your receiving capacity, your memory or your buffer is not enough to grasp all these things in one day or in one session. So probably you'll say, okay, we discussed OSI. Yes. So you're able to understand. Yes. So probably you'll say, okay, enough for today. So probably we'll continue this for tomorrow. So you can just stop the videos, or you can stop the classes, and you can continue the IP addressing tomorrow's part. So depending upon the destination receiving capacity, the source has to sync. Okay. So similar way here also we have something called windowing flow control, which is similar to this one. So in this windowing flow control, what happens is, so it is going to send some random segments, and it will reply with acknowledgement saying that it has received the information. And now when it tries to send 5 messages at one time, the receiver says I can receive only 4 messages. Now the source and destination will automatically sync on 4 messages, so it will send only 4 messages at a time. So these are all the controlling information. When you are doing transportation, these are all the process happens, like identification of service. So it has to identify which service. Based on that, it is going to encode that information into that. And also multiplexing, demultiplexing. Multiplexing, demultiplexing is actually when you are sending the information, we may be sending some HTTP traffic, We may also sending some FTP traffic. We are also sending some SMTP traffic like that. Even though when you're sending multiple informations or multiple services going on the same channel, but each and every service is differentiated, and we call that process as multiplexing. So multiplexing allows you to send your data on the same channel, but still they are differentiated with a different frequencies. Just like an example I can say, if you are watching your TV, so probably on the same cable which you are connecting, the black coaxial cable, on the same cable you are receiving hundreds of channels. But now when you are changing the channel, nothing but you are changing the frequency, because each and every channel is using different frequency. So this is what multiplexing happens in our networks also. On the same cable, where we are connected, we can also watch. So nowadays we have something called DSL modems on the same cable which you are connecting some internet connections. You can even send voice signals. You can make some phone calls at the same time. You can access internet. So now how it is possible? This is called multiplexing. So multiplexing happens in our network where it is going to differentiate each and every service. They will not interfere with each other. And maybe in the LAN you are accessing hundreds of users, but each and every user will have his own information. They will not interfere with each other because of multiplexing. This is something what happens inside your cables. So the same way, even though in application layer, when you're doing some transportation of multiple services, still it is going to differentiate each and every service. We call this as multiplexing, sending multiple signals over the same channel, and then on the receiving end again it is differentiated. We call this as demultiplexing. So multiplexing, demultiplexing happens here. Segmentation, which we discussed, dividing your large messages into small messages depending upon the MTU size, and sequencing, reassembling, error control, flow control. So transport layer is a major layer which is responsible for end-to-end transmission of your data. And these are all the different process which happens in the transport layer. So it's all internal. We cannot really see this process, but this is something what happens in our network. So now once end-to-end transportation of your data is controlled by the transport layer, and majorly as I discussed, there are two protocols which are responsible for doing this. There is something called TCP, Transmission Control Protocol, and UDP. So we'll see these protocols more in detail when we come to our next topic, where we'll be discussing about more in detail about TCP/IP protocols. Okay, so I'm not getting into individual protocols, the differences, the behavior. We'll see more in detail in TCP/IP in our next sessions. Now it's time to move on to the next layer, that is your hardware layers. So here I got the differences here. So TCP, UDP. So I'll come to these differences in my TCP/IP topics. Okay. Network layer. So now network layer is responsible for end-to-end transmission of your data across multiple networks. Now once application layer provides a user interface, presentation layer defines the format for the data, and session layer creates the sessions. And once the session is created, now transport layer will look after the transportation of your data, and it's going to control the flow of information. But again, now when you are transporting your data, the first thing, like similar way, like simple thing, if you want to send a post or if you want to send a mail, nowadays we generally use mailing system where you have to make sure that you provide information where you want to send to address and probably from address. This is mandatory when you are sending an information, because if you don't provide this information, then your data or your required information will not reach the destination. Okay, so now that is what to information and from information. So now this information will be automatically encoded now in the network layer. So now in the next layer, the network layer is responsible for encoding this information over the header, over the packet. Let us see what exactly network layer will do. So now these are your routers. So assume that these are all your branch offices. Okay, so I got my company network, my branch office in US. Maybe you have one branch office in India, you have another branch office in Dubai, And again, you have some multiple branch offices in Saudi Arab or in different countries, maybe in Japan and in China. I got some multiple branch offices. Now I want to ensure that now the information originates from here, where I want to send the information from here, and it should reach my destination. This is my destination, Japan, let's say. So the information now the information starts here. Now it initiates the process here inside your PC. Once it initiates the process, now the main job in the network layer happens here, router. So where a router is involved here. Okay. So once it reaches the router is going to encode the information. Okay. So router is going to responsible for sending the packet, and it will ensure that it reaches the destination here. This is my destination here. Okay. So now the router is responsible for doing this job here. So router, that's what we discussed here. It's responsible for end-to-end transmission of your data across multiple networks. So now across multiple networks, your data is going to travel. So it will go from here, maybe. So that's what we call as routing process. Okay. So router is responsible for doing this. It is going to ensure that your packet reaches the destination, and it is going to use any of the path. Maybe we call that as best route. It is going to use any one of the route best route to forward the packet. So routing is a major topic. It's a vast topic which we are going to cover in our CCNA in our coming lectures. But in simple, I can say router is a device which is responsible for identifying the destination, and it is going to calculate the best route to forward the packet to reach that particular destination. Okay. So now there are two protocols which are responsible here, which we discussed just now. Routing protocols. Routing protocols are responsible for path determination, nothing but selecting the best path, which we discussed just now. If you have two routes, it is going to decide which route is the best route. And the router is responsible, and this process happens inside your router actually. So that's the reason we call a network layer as a layer 3, okay, which is a layer 3, and router is a layer 3 device. And it is going to do that based on source and destination IP addresses. Now, the to and from address, whatever we discussed here in our example, so the router is going to forward the packet to reach the destination, and this destination is identified with some address, and we call the IP address. So the devices, source and destination identified with IP addresses here, which means here when a packet reaches the router, it is going to encode it with your normal information, which is your data, and then it is going to add it with some extra header information, and that header will contain what is the source IP address from where the packet is coming and what's the destination IP address. Based on that information, it is going to forward the packet to reach the destination. Okay, that's what logical addressing we call it as a, or path determining the path route as described in this layer. That's what we call as logical addressing, nothing but IP addresses. So there is another protocol we call as routed protocols. Routed protocols are actually data carriers. They carry the data. So in our networks, in today's networks, we are using TCP/IP protocols, which are considered as our routing protocols, routed protocols, which we use. These are the actual core routing protocol which we use in our today's networks. So AppleTalk is a protocol for Apple machines. IPX developed by for novel operating systems. In today's network, we generally use TCP/IP because of internet. Internet works on TCP/IP. So here in this layer, we need to remember, make sure that router is a device which works in this layer, and these are the two protocols which works here, routed protocols and routing protocols. Routing protocols decide the best route, routed protocols are acting as a data carriers. Now once we understand the network layer, the next step is to understand data link layer. Now the data link layer is also responsible for end to sending the data by within the network segment. Within the network segment means this is within the LAN. So which we discussed in our previous layer, network layer, which we discussed, it's more deals with a WAN connection. So whereas once the packet reaches the router, so now within the LAN, how the process happens. So this process in the LAN is something what data link layer, the process defined in the LAN is your data link layer. That's what it defines. So the process happening on the WAN, basically routing part, is defined in your network layer. Okay, so let's see what exactly the process here is. So now here also in the LAN, when you talk about LAN here, now we are sending some information here. Now just now we discussed the router is going to do routing job. It is going to send the packet to the router. Now once it reaches within the LAN, here let's take an example. I got some switch connected and some computers. Now within the LAN, each and every device is again the packet is arriving here, which means this is my source address and I want to send the packet to this destination. Okay, now within the LAN, they are not going to identify with IP addresses. They identify each other based on the MAC addresses, which means internally there is a protocol called ARP, address resolution protocol, which is going to convert your respective IP address into MAC addresses. We'll see again ARP functionality more in detail in our switching concepts. When we start our switching concepts, we'll be seeing more in detail about these things. Okay, so whatever the process happens in our LAN, mostly this is your data link layer. So in this data link layer, it is going to send the information from one device to another device based on MAC addresses. Now switchers maintain this information. They know exactly on which port number, what is the device connected and what is the MAC address connected. So MAC address is a hardware address, or we call as physical address, which is by default when you connect any device. So any device in the network, it can be a router, it can be a firewall, it can be a switch. Every device have a unique MAC address, and the switches will maintain that information of which device connected on which LAN. So more in detail about this process you will understand in our switching concepts, where we get into more in detail about switching, how they work, how the devices understand the MAC address, how ARP is going to work. But the main job in the data link layer is we call as layer 2 job, where the devices are identified based on the MAC addresses. And that's the reason we call the MAC address as a layer 2 address. So apart from this, there is something called CRC check. We call it as a cyclic redundancy check, where whenever you are sending any frame, now this frame or data, whatever you are sending, will be automatically checked for errors. So it is going to run some random algorithm, and in case if it finds anything, it is going to drop the packet and it is going to send a request to resend it again. Okay, whereas it is going to check for errors. That's what we call as, and in case if no error found, it is going to send the destination. So this is called, we call as frame checking mechanism. Inside the switches we call as CRC check. Okay, so most of the switches will do the CRC check in general. Now once switches provide end-to-end delivery of the data within the network segment, now the next thing, and there are two devices which works in this layer, we call that as the switches and bridges. Switches identify based on the MAC addresses. Bridges are no more used in today's networks, but in general, bridges are the earlier version of switches, we can say. So bridges are software based, which are not much used nowadays. Nowadays we use the same software coding has been integrated on the chip on the switches, which means you have the same programming inside your switches, but the switches are more flexible devices. Now finally, physical layer. Now this physical layer is responsible for end-to-end transmission of your data inside your network segment in the form of zeros and the ones. Now when you're sending some information, now the entire information will be automatically converted to zeros when it is transmitted over your physical cables. Now when you're sending the information over the physical cables, let's say I'm sending the information through copper wires connected in my LAN or in a WAN. Copper wires, you'll find your UTP cables, unshielded twisted pair cables, which we use to connect in our LAN, or it can be a coaxial cable, which we use, the black cable used in your cable TV connections. They go in the form of the entire data, whatever the data you are sending, it will be automatically converted into your binary zeros and the ones, because the devices understands only binary zeros and the ones, and these zeros and the ones are again in turn converted into some electrical form signals if it is going via copper cable, And if it is going on a fiber cable, it will be automatically converted into some light signals. And when it is going over wireless, it is going to get converted into some radio frequency signals. Now your data is traveling over this media, we call this as physical media, in the form of signals, and this your information is converted into this form. So we call this process as this process comes in a physical layer. So these are all the things happening in our network, starting from application layer to physical layer. So let us see the process of physical layer again quickly. In a quick steps, we'll see the process of physical layer here. Like here you can see, this is my information here. If I just take the information here into my, let's talk, if you see here in our information, like initially we started application layer information will be in of data, normal data, whatever you are sending. And when it goes to reaches the presentation layer, it will be in a normal data, because presentation layer defines in which format the data has to be sent or received. And then session layer is just it is going to maintain, create, maintain, and terminate the sessions. Now when you talk about these three layers, now these three layers are actually internal process, and there is no modification of your information when it is here. Okay, when you're sending the information. So when you're sending the information, there's no changes. Okay, it is in the same format which was there before. Okay, so now the next thing, when it reaches the transport layer, your data, whatever the data you're sending, it will be in the data only, will be added with some extra header information. Extra header, nothing but extra, just like extra sticker or extra paper added to the existing information. And this header will be having some information about your sequence numbers. If you remember, transport layer, it will identify the service, and identifying the service based on the port number. So that port number will be written over there, so that, and then which protocol is going to use for transportation, whether TCP or UDP information, and it's going to write sequence numbers so that it can be reassembling at the end. And also it is going to write the flow control information, windowing flow control, what is the size of the flow control information. So all this information will be added into that, and this format of the data we call it as segment. So when it says segment, nothing but you have to understand that the existing data is added with some extra header information and reaches the next layer called transport layer. Nothing but when it reaches the router, when it reaches your router. So once it reaches your router, now this segment, whatever the segment we have, this segment means nothing but your data with some extra header information is added with some extra header information again, and we call this format of your data, we call it as packet. You can see here it is called as packet. Now what exactly this header is having is, header having the information about from where the packet is coming, what is the source IP address, and what is the destination IP address. Because in the network layer, routing process happens, and the router should know from where the packet is coming, where it has to go. Okay, so that information will be added. So once the packet reaches the data link layer here, now again when it reaches the data link layer, again what here happens is, now this data link layer is adding some more extra information. So now this particular I can just remove all these things. So now once this data link layer is going to use the packet information, and it is going to add some extra header information again, and this header information will be having the source and destination MAC addresses. When it comes from transport layer, when it reaches the devices, the switches will not understand IP address, they only understand MAC addresses, and there is a protocol called ARP which will resolve the IP address into its equivalent MAC address. Now which means the data link layer, the process happens, identify the device within the network segment based on the MAC address, we call it as a layer 2. And finally it reaches the physical layer, nothing but reaches the cable or a copper wire, where the complete information is sent in the form of zeros and the ones. The complete information goes in the form of zeros and the ones, which means when you are sending the information, it is coming in the normal format data. If I talk about layer 7, let me write down the layer 7 here. So initially it will be data. So here, when you are sending the information, it will be in a normal format like data. It will be going in a normal format data. And when it reaches here, it is going to convert into segment. And when it reaches the network segment, it converts into packet and then frame and then bits. So now, while you are sending the information goes in this format. So this is what we can say while you are sending the information. So on the receiving side it goes reverse, which means the information goes in the form of zeros and the ones, and once it reaches a network segment, that is nothing but data link layer, it gets converted into frames which contain source and destination MAC addresses. And once it reaches the router, it gets converted into some packets which contain source and destination IP addresses. And then when it reaches the transport layer, it gets converted into some segment which contains the TCP UDP information. And finally, session layer is again maintain that session, and then presentation layer will decide the format, and finally application layer where you can see the information. So if you try to observe here, when you're sending the information, it is in a normal data. When you're sending the information from this side, it will be in a normal data, and when you're receiving the information, it is in a normal data. But in between, there is a lot of translation or conversion, or there's a lot of process involved here, and there is a lot of devices involved here, like there's a router involved here, switch involved here, physical transmission devices involved in the physical layer. There are a lot of things happening here in the network. So this is what exactly OSI is going to define you. So OSI is going to give the detailed description of how the communication is happening. Okay, so in general we discussed a complete detailed structure of your OSI model, but there are some few important things we need to keep in mind in the examination. Like, you may be tested in your CCNA exams. The main points which you need to keep in mind: you need to remember the layered architecture, the layer names. You have to remember the names in order, like first physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. And you have to remember the numbering as well, because you may be tested, like you may be asked some questions, maybe a router works in which layer. So you may get an option layer 3, or you may get an option called network layer. So you should be well familiar with the names or numbers also. That's the first point. I really suggest you to remember the basic things. And the next thing, you need to understand what process happens in which layer in 1 or 2 lines. The same which you can refer my notes. If you can remember that, that will be enough. And also you need to remember which hardware devices works in which layer. Okay, this is the next thing we need to keep in mind. Which device, like router works in a layer 3, switches, bridges works in a layer 2. Physical layer, we have copper media cables. Not only cables, physical media also. Hubs comes another category. Repeaters, we don't use them nowadays. And transmission media, the cable, comes in your physical layer. We call that as layer 1, because the actual formation of your data starts here. That's the reason we still call it as a layer 1, whereas the actual sending of data starts from the application layer, but received on the application layer again. But the actual formation of the data starts from the physical layer. So these are the points which you need to keep in mind in the examination point of view, because you may be tested some multiple questions on it. So you should be very much comfortable with these things. Okay, so thanks for watching. In the next video, we'll be discussing more in detail on TCP/IP protocols which we use in general.